Good morning, everyone. Welcome back. How's it going so far? Chapters 1, 2, and 3, right? Questions? Okay, making progress again. Um, and it's part of what you learn in this class is time management. So there's no strict due dates. But remember, we're now into chapter 4. We've got 5, 6, and then our midterm. So just block out your time to get done what you need to get done. Um, And today we're going to see a sort of connection between chapter 2 and 3. So 4 is going to take a look at both of those things. So it's, in a sense, not completely new, but there's going to be a few newer things that we're going to do. Um, and so I've let me rearrange this module a little. I'm going to take this because it's just makes it busy. I moved it inside. I'll show you that in a moment. So we've got our lecture. We'll go over that. There's a couple links here. There's a link to Desmos, which is a graphing calculator. That's what we're going to use to do our regression, what we're calling. What that is taking data, plotting it on a graph, and either fitting a line to it or fitting an exponential, which is a sort of a J curve. So that's what we're doing today. You can do this all. If you look at the textbook, they show you how to do it with a TI-84 handheld calculator. And I've seen a couple people who are working ahead, and that's how they're following the textbook. That is perfectly fine if you're comfortable with that. I just find that the Desmos is much easier to use. It's online. You will be able to use it for the exams. Um, so it's a good resource to have, and so we're going to go with that. There is this regression with Desmos. It's a link to a recording of how to specifically do exactly what we're going to do today, done by somebody else. So if my instructions aren't real clear, maybe somebody else's instructions will be, or they're specifically for it. They're not focusing necessarily on the questions from the course, but we will look at how we take these questions from the course and how we use Desmos to get the answers we need. Okay, uh, but that's there. Textbook is there, and then of course the homework in the chapter 4 quiz, and we will go through a lecture process. We'll work through things together. If you want to have your computers open and kind of working along, because that's in Desmos, that's helpful. So if you just pull up Desmos, and we'll put other things up here, and you can kind of follow along. Please do ask questions. If you get behind, don't think, oh, I don't want to bother him now. Let us know, because maybe there's one button that you need to click that you missed. And if you click it, you'll be able to keep following along. If you don't, then you get further behind and you feel lost, right? So please do uh, any question, ask it, um, and we'll go from there. So in the lecture part, I've got a little presentation that I've got everything stored in, so we're going to go through that. There's the recorded one from the 140 class, which comes after this. They did it last week. Um, so that's there. And then there's one from last fall. Um, and again, this one was a little different, but it's there just in case. Um, but once we finish today, I will put our link, our Math 141 link, right here. So that's kind of each time you go back into the modules, the recorded lecture, if you ever miss a day, or if you just want to go back to a day you were here but refresh it, it's always going to be kind of like this. There'll be 2 lecture recordings, one from the other class, one from this class, um, as long as we don't have technical problems. I do that because we got a backup, right? Something doesn't work with the recording, we go there. So I'm going to open up this presentation, and we're doing something called modeling. Um, how many of you have built like model cars or model even those little buy those little kits, those plastic kits? Anybody do that? No? That was one of my I love doing those. Get those little boxes, make that little. I couldn't buy a Corvette, but I could make a little model of a Corvette, right? Um, so modeling. Let's see, where do I want to go? I want to go to the slideshow. And I want to open up my pen. Oh, that's right. I had to sign out of everything. So let me get signed back in. Which one did I use? I think I used that account. Let's see. Oh, it's not that one. Well, let's okay. This is the right one. So again, this is about taking data, and we are going to either fit a line, a linear equation with straight line to it, and so that gives us something to predict. So maybe we're running a business, we know how our sales are going, maybe we can predict future sales. Um, and so that's what's called linear regression. Linear for the line. Keyword here is line. Regression, I looked it up one time because it's kind of a weird word, but it means to kind of get back to the data, to the points, and try to sort of average them out, is what we're doing with either a line, or if it's a percent growth, we're going to get to that, which we did in lesson 3, right? Chapter 3. Then we're going to do exponential. So the two types of equations we're working with, does anyone remember linear equations? Yes, y equals mx plus b. And if you remembered what we put into Desmos to do the regression, we don't use the equal sign because it's kind of, this is like computer coding and programming. We use a little approximate symbol called a tilde. We do put in m, we put in x plus b, except the y and the x are not just y and x. We do y1 and x1 because we put our data into a table that is x1 and y1. It's just how Desmos works. Okay, so that's so the key part is when we're doing this, we have to remember this is what we're going to input. And remember, you can, when you sign into Desmos, you can go through your Google account and you can store this. You can save it so that you could just pull it back up, put in new data, and it will all work. So you don't have to necessarily memorize all this stuff, but that's what we're going to be doing with that. While we're doing that, we're going to add a new topic today called correlation. And the key part of this word is relation. What is a relationship? What do you need for a relationship? Two things, right? I guess you can have a relationship with yourself, but that's not what we're talking about here. So a relationship between two different things. So we're going to have an X and a Y. And so if I know what X is, can I predict what Y is? That's good correlation, a strong correlation, knowing what X is and being able to sort of predict Y. If I know X and I am is sort of not a very good predictor of Y, it's not good correlation. Okay, so that's what the word means, is we're going to look at, and we're going to be able to tie it down to a number. And again, Desmos does all of this stuff for us. We don't have to go into formulas and like I used to do 40 years ago when I was learning this stuff. We didn't have all this technology. We had to do formulas and by hand and calculate and make a lot of mistakes. We're just putting it in and it's all going to be good. Okay. And what we'll see is that what we're going to be looking here, just to give a little, it's going to be R equals some number. From that number, we're going to know whether it's positive correlation, which means as one goes up, the other goes up, negative correlation, as one goes up, the other goes down, or no correlation. Okay, so by that number, we'll be able to tell a lot. We will be doing exponential regression. So let me just highlight. Does anyone remember what kind of equation that was? That was just from the last lesson. It was y equals exponential. We used some different letters there. We used the letter A times B raised to the x power. Okay, so that's how it's going to look. And remember, in this case, A was the starting value or the initial value. It's how much sort of like initial. When we, and this will tie into what we do next week in financial. So if we deposit some money and we're getting some interest on it, we use this sort of stuff. So A was the initial value. B was 100%, either plus or minus, it depends if we were increasing or decreasing some percentage rate. So I'll just put rate. So if our money's growing by 5%, it's 100 plus 5, we would see 100.1.05 in there. Okay. If our money, if we were losing money by 5%, 100 minus 5, we would see 95% or 0.95. Okay, so that's kind of what happened there. And then again, for when we go to Desmos, how we put that in is very similar, but we don't use the equals, we use that tilde, we use y1 equals, we'll use the letters A, B, and then x1 will be up here in the exponent. And a lot of the questions, they'll give us some data, they'll ask us to find the equation, and we'll go into Desmos, we'll put in our data, we'll have Desmos do it for us. So this lesson is about how to do that, okay? And that's why I have it recorded. It's so when you're not here, you could go to that part of the recording and watch the steps. Had a friend who I was learning some programming for the MORE program. We actually program in those questions. And we had one of our faculty here who knows how to do that, was teaching us. When he made little videos, it was so much easier because when he was doing it, it was hard to follow along, but when I was doing my own homework, I could pull up his video and follow along, and then, oh yeah, that's okay, I'm missing that little button push. So that's why we have this. And then 4 is just putting it all together. It's not anything new. We're just going to take some problems and take that data, and either we're going to have to choose whether it's linear or exponential. And again, one of the key things is we're going to come back to this R, and that will tell us which one's sort of the better fit. So that's the big overview, and let's go ahead and dive in. Any questions, concerns? Okay. And in the Canvas, I just added it this morning, but there's a link to Desmos. So if you don't, and you could type just desmos.com and then go to the graphing calculator, or you could do desmos.com/calculator. That takes you right into the graphing calculator. Or you could just click on the link in Canvas. But again, that's kind of what we're going to work in today, is learning how to do this. And it will take time. We'll do it together. And then, as we're doing the quiz, we'll do it. And then on today's Wednesday, Monday, we'll come back with a work day. And again, you'll probably still have some questions, but we'll work through it together. But we'll be able to get all our answers from this. Okay, so first of all, what we're going to do is we will put in our data. We'll have some set of data. And so in this case, our data consists of age and some kind of value. So and this might be, say, the car. As it gets older, what's happening to the value? It's going down, which unfortunately sort of happens with just about every car. Unless it becomes a collector, then it might go back up. But most cars, over time, it goes down. What's linear regression is Desmos takes a look at these data, actually does some calculations, but it's going to fit a line to this data and sort of average it out, something like that. Okay, so that's all it's doing. It's going to take that line for the linear regression, because the data sort of seems to be going along there. And then what we are going to be able to do is, if we want to make a future prediction, like if when the car is this age, whatever this is, we can say, oh, this is about what the value should be. Now, it might be a little bit off one way or the other, but it's taking the average out. If we wanted to know the starting value of the car, we could come back here and say, oh, it must have been this, right? Because the line would go the y-intercept, that when it was new, it must have cost this much. And maybe in between, we wanted to know, we could do a lot of different things, but we can figure out, use that line instead of the data. Okay, so that's what we're doing. And you'll see it's not so bad. We'll go through the process of making these. Any questions? So here we are. We've got a tree farm, Christmas tree farm. We've got some years, and we have production. And it must be a pretty big one, because that's in millions. It wasn't just 27 trees, it was 27 million trees, 27.1. One of the first things we do, because we're going to dive right directly into Desmos here, is when we're using time, and in this case years, 2004, if you make, a lot of times your time is going to be your x coordinate. If you're on a graph and you're out at 2004, you're like way over there, right? So what we do is to say, we want to just sort of center the graph. And so what we're going to do, I think we've done this before, haven't we? We usually will make that first year, hey, that's the start. We'll call that year 0. And what that does is it forces this out, now becomes our y-intercept as well. So we've moved the graph all the way over. And then, so if that's year 0, what's the year 2006? 2, because yeah, be careful, we got to watch it. They don't always, yeah, it's the next data point, but they didn't have one for 2005. So this will be 2. And then here, another 2. Okay, so that would be 4. And then we're going up another 2, 6. Oh, but be careful, this didn't go up by 2 now. It only went up 1, so that's 7. So we're, and again, if you're not sure, you could always say, okay, 2011, and we started in 2004. If you subtract those, you will get your x value as well. So, you know, if you're, I like to count on my fingers, but however you want to do it, okay, you'll come up with that time. So what we're going to use is, these become our x values here. These will be our y values down here. We're going to go into Desmos, call up a table, we're going to put them in, and we're going to see them plotted on a graph. Right? So we're going to keep this stuff. I don't have Desmos open, so again, you can click on the link in Canvas, or just go to desmos.com/calculator. And it takes you right into the graphing calculator, hopefully. Oh, there we go. Okay. First thing we want to do is we want to tell it our data. Okay, so to do that, we hit this plus button. Notice the plus, we can do an expression, a node, a table. Table's what we want. We can add folders. We can actually add images. So it's really there's a lot of stuff you can do with this, but what we're going to do this time is we just want to add a table. We have our x values and our y values. And again, sometimes you might want to like pull it off, and then it's nice if you have 2 screens, right? You know, if you can have multiple screens and have them all up at the same time. If not, let's see, oh, I can do okay. So I've got my x values. I'm just going to put those in. I'll go 0, 2, 4, 6, and 7. And then I want to put in the y values. And again, this is where it's important. See if I can, because if you don't get them in right, even if it's off a little bit, you won't get the same answer. It'll be just a little bit off. And my problem is I transpose, and sometimes those are hard to see, because you you think you're putting in the right thing, but your mind somehow twists it on you. But it's the most important part of it. And if you're not getting the right answers, that's typically what has happened, is that you didn't get the right numbers in. And sometimes I'll look over them 2 or 3 times and I say, but I got it all right. And then finally somebody else will look, no, you got this one off. You put a 6 instead of a 5 or something. And that's enough to make a difference. 28.2, 27, and oops, 30.8. So then 30.8. I feel pretty good. Let's just do a double check. Everything's in there correctly. All right. So I'm going to again, you're going to be doing this in the homework. They give you similar tape. In fact, I think I took this out of the textbook, but they'll give you a table like this. You're just getting them in there. And again, it's nice if you have 2 screens and you've got one over here and one over here, but that's what we got. Okay, so now that we've got those in, that's one of the key parts. Now, the one thing is it'll be nice to see that data, but we don't see it, do we? Now you can zoom in and out. Oh, there it is. It's all up there, right? One of the things you can see is our x goes from 0 to 7, so we're okay this way, but our y goes all the way up to 30, right? So we can adjust that with this little wrench. This is a settings, graph settings. So we can make our x's, maybe I want to zoom in a little bit on this. I like to see my y-axis, so maybe I go from -2 to 10. So that's out to 10 years, kind of zooming in a little bit. And then I go with my y's, let's go from, I don't know, -5 to 30, 40. I'll go to 40. Okay. So we can see all the data. Does that look like it's sort of linear? Like we could fit a line? Kind of looks like maybe it's going up, and we could kind of see a trend. This went up, that sort of stayed equal, went down a little bit, then went up. So if you were thinking about a line, again, we could eyeball it, and let's see, just kind of average it. I'm going to leave this one here. See this, not run it up a little bit. Yeah, that's not quite right, but that might be my best guess. So if you're eyeballing something like this, right? What we're going to do is going to get Desmos to give us the actual one. It'll do all the math part. It actually takes those and the values and fits the best line to it. Does anyone remember how we go about getting the line on there? What are we going to put? The Y. So again, a couple ways. You could actually come here and just hit enter. If you do, well, switch over here. I guess you can't. You could also go to the plus. What we want is an expression, an equation. That's what they call an expression. So we get a new line to put that expression in. And remember, we were putting this, we're going to put in y equals, but not just y, because our data is y1. So we'll put in y1, and I just hit the y and the 1 key, and it automatically puts the little sub 1. Don't have to do anything special. Instead of putting equal, what do I put? That tilde thing. I'll come up here, and so you can see it from this keyboard. It's this little, it's right there on the ABC keyboard. It's that tilde, it's not the equal sign. And then, because I got to come here anyway, mx plus b, right? mx, oh, but not just x, I want x1. There we go. Starting to get the line, and then I do a plus b. And I come back here, pull up a b. Whether you use m and b is not really important. Those are just kind of, we call them dummy variables. But what it's done is it has given us the equation of the line. And look, at their line is better than mine, but mine wouldn't let me get it the way I wanted, but I had the right idea. It was kind of going to follow those points, right? But this Desmos is actually calculating it, making it the best fit. It gives us our parameters. What do we call this parameter of m? That's our slope, good, which is our rate of change. So each year we could say it's positive, so it's going up by 0.27 million trees is basically, that's how you think of the slope. One more year and we've sold another 27 million trees, 0.27 million trees. So slope. And then what is B? B is kind of like here. It's when x is 0, so it's the starting value. So basically, so what we're able to do, a lot of times the question is going to be, they give us the data, what is the equation of this line? So you just take these two and you put them in their place, and your answer is going to be y equals 0.279. Usually they want it rounded to 3 decimal places, but check. If they say 2 decimal places, they want 2. If they say 3, put 3. Otherwise, it marks it wrong. But that's typically, and so I got it wrong. No, you didn't. You just one more decimal. Or so read the instructions. I'll be honest with you, I don't like to read instructions either, but there it is. So that's the slope times x plus the value for b, which is 27.28. And sometimes they want this just to 2 decimal places. Sometimes they want it to 3. So again, look at the instructions. But we just use Desmos to do a type of problem. Here's some data. What's the line that fits it? Okay, so you're going to see some of this in the homework. So far, how we doing? Okay, now let me get rid of my extraneous line here. I'm going to delete everything. Yeah, we'll just, oops. No, yeah, we'll go ahead and do that. So that line's gone. So when we look at this line that they fit, maybe we'll change it. It's black. So maybe the other thing you can do with this is if you click and hold on it, you can change it to whatever color you want. Maybe you want to make it red so there's a little bit more contrast. We'll do that. The other types of questions that come up are one question they'll ask is, how many trees were sold in 2013? How could we figure that out? Because our data only goes to 2011. So what do we need to do? We could use that slope, but how would we find out what is the y value, how many trees were sold when x is 2000? Well, when it's year 2013. First of all, is x going to be 2013? No, because we changed the years into years since 2004, right? We made 2004 year 0. So what x value is 2013? That's actually year 9, right? Did I get that right? 4 from 3, yeah. 4 from 13, 9 years. So we're going to use x equals 9. What we're going to do is we're going to use this red line, and we're going to find out when we put in x equals 9, what is the y value. Now, one of the things is this red line is using this full decimal that is here. When you're doing your homework, the Moore system is going to ask you to round your equation, okay? So what you're going to need to do so that your answers match what they have in Moore is you're going to need to put in the rounded equation, okay? So let me just kind of show you how to do that, because again, This is what we're going to do. We'll do it with the quiz as well. We're going to add in the actual equation, which is y equals 0.279. We're rounding to 3 decimal places. X plus 27.28. Let's say they said round the B1 to 2 decimal places. So we're following the instructions. This is what we told Moore was the equation. We now have it here. I'm going to change its color to blue. And you see it's pretty close, but it's actually going to give us slightly different values, okay, to be accurate. I'm going to turn the red one off. I'm going to press, actually I'm just going to click on it. That turns the red one off. Now I'm going to use the blue one. Okay. And this is just from experience. If we use the other one was very accurate, and that's usually what we would do when we're doing research. But to do the homework, if they want us to round, we have to round here. Okay. Now, this is the cool part. To find out what is y when x is 9, I just do one more thing. I add the expression x equals 9. When I do that, and I'm going to put it in a different color, let's make it orange. What I see now is I get an intersection between the blue line and my orange line. This is where I get my answer. So after 9 years, which is the year 2013, we were predicting that 29.79, rounded to 2 decimal places, Christmas trees are, millions of Christmas trees are being sold. Okay. So again, here, what we get here is we get our answer. Okay, so that's our y value. So notice we did, now we also could have plugged in 9 to the equation itself and sort of done it with a calculator. We would have got the same answer. You could do that, but I like doing it graphically because you can kind of just see it. It's a visual way of doing math. So it's kind of your choice how you want to do these homework problems. Okay. What if the question had been, maybe you're thinking, how long will it, if we keep at this rate, how long do we get to sell 30 million Christmas trees? We can answer that question as well. What 30 million is what kind of a value? X or Y? It's a Y value. So we're going to just put in, instead of X equals 9, we're going to change this to Y equals 30. And again, that's whatever the question is asking. And look what I get. I get a horizontal line. And I can move this over. I can see where they intersect, the blue line and the orange line. I click on it, and it tells us in 9.7 years, we're going to have 30,000. So maybe we round it to 10 years, so that'd be about the year 2014, right? 9.7. And again, sort of to get it back to, and usually they want you to round it to the nearest year, so we'd round that up to 10. How do we figure out what year that is? Well, we started with the year 2004. We add 10 to it. That would be the year 2014. We are connecting y equals 30, or the line y equals 30 with the regression line that we came up with. And again, visually, all we have to do is find where those two things cross. And for us, you just have to kind of go where those lines are and start clicking, and it will, Desmos shows you that exact answer. Again, you could have done algebra. You could have put 30 in for y and solve the equation. That's how the textbook sort of teaches you how to do it. With this system, it's a lot easier to me, just put y equals 30 or whatever it is, and then go find that intersection. And the other thing is you're seeing it graphically. Did you have the same equation? You put in y equals 30. Okay, did you put the rounded version in? Let me show you. So let me take this one off. I'm going to put in the original one that's not rounded. This is what you got, right? 9.757. So you're using so this is, I thank you for doing this, because this is typically how we would do it if we're doing research. We use the data, but notice we're using unrounded data. The Moore system, the homework would say we were wrong because when it said it only wanted the rounded data. So I put in this extra equation with the rounded data. Notice I've got 0.279 for my slope. The actual data is 0.278659. Okay, so that's why we're getting a difference there. And that's why the homework's saying you're wrong when you're not really wrong, you're just more accurate. So we're kind of backing off. Okay, it doesn't want me to be that accurate, so let me use the same equation I told the homework that we're going to use. Okay, so I had to put this one in. This one has a slightly different answer. Make sense? Now, if they ask me to round to the nearest year, we both would come up with year 10. Okay, so sometimes it doesn't matter in that case, but there's going to be times when, yeah, we're just off by a few tenths, but they mark us wrong when we're just more accurate. Okay, and it becomes especially important when we're doing the exponential. Will be very different. So we can do it this way. Or the other thing is, again, you can plug into the equation and do it by hand, but that's kind of tedious, and but we'll work with you either way. Okay, so just remember this, that when we go to these type of questions, if they want the values rounded, we need to put those in, and turn off our very accurate regression equation. Okay, and that's pretty much it. That is what we're doing. And then we're just going to do it with all the difference is we're going to see the other data with exponential is going to be a curve, and it will fit a curve. Okay, so but the details are about the same. Yes, I rounded. They said the nearest year, let's say, in the question. So 9.7 years, we round that up to 10 years. And again, we have to sort of also follow the instructions, which if you've seen me, I don't always read all the instructions, and then we get it wrong, and then we say, oh, why did we get it wrong? Oh, they want this. They want it not as accurate. So we're pretty close. Good. Okay. Questions? You okay? Okay, so I'm going to go back a little bit, and I'm going to talk about the next thing called correlation before we get there, and I'm going to show you what Desmos is doing. So I'm going to delete this rounded equation just to get rid of it. I'm going to turn back, and I'm going to delete this y equals because that's not part of it. I'm going to turn back on the regression equation. I'm going to move this over so we see. Now, you see the red line, you see the green dots. You might be different colors on yours if you're following along or trying it. Are the points, the data points, are they all on the line? No, they aren't. So the line is not completely accurate. It's not matching the data completely. It's averaging out the data to kind of get sort of what we call a best fit, but it's not an exact fit. In fact, what I want to show you, this is the idea of correlation. But would you agree that overall these points are going sort of up, or there does seem to be somewhat of an increase? And again, some increase and then some decrease, but overall, we'd say it does have a slightly upward trend. This is what we call correlation. It's not perfect. It's not a perfect correlation. Perfect correlation would be each point was on the line. It's a perfect linear correlation. The way we talk about correlation that's an idea from statistics, is we look at this value, this R value, R equals, in this case, 0.51. I'm going to go back. So this has a correlation of about 0.51. What that means if it was a perfect correlation, that R would have been 1. And we'll look at a few slides to time this out. It would have, each point was on there, it means no error. It's actually would be 1. So but it's less than 1, so it's not that strong of a correlation. Typically, a strong correlation is about 0.7 or so. It's not a strict science, but we would say it's strong. 0.5 we'd say is sort of a medium correlation. And that's what's happening here. We can't always accurately predict because sometimes we went down a year, then we went up a year. So we don't know about the future, really, right? We could have gone down another year, bad economy or something. People buying artificial trees instead of real trees. So, whatever's happening, it could go down or it could go up. So that's the correlation thing. And so but what I want to show you is your Desmos will give it to you. So some of your questions will ask about what is the R value or what is the correlation. Desmos is going to give it to you. Okay. And if you take a statistics course, you'll learn what the R squared, that's something different. We don't deal with it, so I'm going to leave it out there. But you'll deal with that. And you can use Desmos to do some pretty advanced statistics, which we do later on. So maybe we'll come back to this. Yes.
How do you get the one before that one?
This?
Yeah, how can I write everything? Like hit the plus
sign? Let's see. Yeah. If you do we did the plus sign. You have to put your table in, and then you have to put the expression in. It's basing it all off of this expression y1 tilde mx1 plus b. So this line is what tells it to find the equation. And we're going to see, we'll use it again when we get to exponential, but we get a different equation and it will still fit that equation. There's a lot of power here. Okay. So we're going to, and again, it's kind of learned by doing. So I think that's enough. We're come back here and back to the slideshow. We put this in. Correlation, what is it? We kind of talked about it. It's how closely those points, those data points fit the line. Perfect would be all in a line. Strong would be kind of close to that line, but all kind of going the general way, but not exactly perfect. And a weak is just kind of scattered maybe all over the place. And then there's also correlation that goes downward. So that's if things are decreasing. Things like golf is a game, the better you are at golf, the lower your score, right? So you practice a lot, you get good at it, your correlation should be the more you practice, the lower your score. So that would be a negative correlation. The other one is, you go weightlifting, the more you practice your weightlifting, the more weight you can lift. Okay, positive correlation. And then there's this no correlation where it just sort of looks like a random thing. Okay, you really could almost draw any line through this, and none of them are going to be good. So, and then with that, this is the value of R that Desmos will calculate. So R equals, if R is 0, that's no correlation at all. -1 would be a negative correlation and strong. So there's got both ends of these are strong. So -1 would be really a perfect negative correlation. +1 would be a perfect positive increasing correlation. And in between there, we get strong, weak, to nothing. Okay, moderate maybe. So we get values from -1 to 1, 0 being no correlation, and then here we'd get like 0.5. Here we get -0.5. And as far as the strength of correlation, -0.5 has exactly the same strength as +0.5. It's just going downward instead of upward. But as far as the fit, it's all going to be the same. What we're going to do is, as we move into the next type of regression, which is exponential, we will use this R value to tell us, is it linear or is it exponential? Which one's a better fit? And we'll look for the better R value. And again, a better R value is it's either closer to +1 or to -1. It's going to be the better fit. We doing okay so far? Okay. So now we're into our last section before we get into the applications. And for applications, we'll just jump into the quiz because that's where they're at. Now, does this look like, we see this data, does this look like a line would fit that very well? It looks a curved line, and that's what an exponential is it will behave something like this where it'll start to, oh yeah, that looks more exponential. So that's when we have a percentage rate change. So our rate is a percentage change, not a set, amount of change. Linear is an amount of change. Every year we're getting this many more. Exponential, every year we're increasing by 2%. That's a percentage change. Okay, and we'll see that that's exponential. Okay, and then we'll do a problem with exponential. It's all pretty much the same as what we did. The only thing that will change is the equation we put in. Okay, so from data to scatter plot to equation. We need some data. So this is some population data, and oftentimes population grows or shrinks exponentially. So we're going to plot this data, and we're going to have Desmos give us the regression model. We ready? We're going to keep, and notice they already, it's kind of number of years. It's not date years, but it's 0, 1, 2, 3, 4, 5, 6, all the way to 16. So where's my Desmos? Bring that back. What I'm going to show you, let me clear these out. I'm going to leave my table, but I'm going to come here to the end and I'm going to delete. So I'm hitting the delete key or the backspace key to get rid of the data. There we go, almost. And then now I'm going to put in the new data. I'm going to, rather than get rid of this one, I'm going to, well, I actually can't do anything. Let me just put my data in first. Again, I can kind of move my windows around so I can see what my data was. That down. Let's see if I can get it all in here. So we'll put in 0, 1, 2, 4, 6, 9, 12, 16. And I'll come back and I'll put in the Y values, 125, 75, 50, 32, 22, 16, 10, and 5.7. So I've got my data in there. Be okay? Give you a second, I'll enter those in, and because that's really all you're going to do through the homework is we're going to use this a lot to do the graphing. And again, I know it's a little bit of a learning curve, but believe me, it's much easier than using a TI-84 handheld calculator. Unless you're very used to it, then I've used it before. I still like this one much better. Be okay? And again, what should we always check our data, because if we make an error here and what we put in, there's no way we can get the right answer. Okay. So now I'm going to fit my data to the window, or my window to the data, right? My x's are going from 0 to 16, so I'm going to come to my wrench, which is the settings. So I want to make sure my x-axis goes at least from 0 to 16. Actually, I like to go from maybe like -2 to 20, so I can see all the values. And then my y values, I'm 125 down to 5. So that's my y values. I'll go from -5 is good to, let's go to maybe 150. And when I've done that, I can see all my dots. My linear equation is still here, but does that look like that linear equation fits it very good? My y, I went from -5 to 150. And all I did is I looked at the data. I just want to make it big enough. You could have gone to 200 and you'd be fine. But so it's kind of an art form. You can also use your fingers and pinch out or pinch in. It's kind of nice. You can grab it and you can move it around. But does the line look like a very good fit? Not really. And you can look at this R value. It's negative because it's going down. It's not really a very good R value. So I'm going to turn this off. I'm not going to delete it because I might need it later. Because in your homework, sometimes it'll ask you to do linear, sometimes it'll ask you to be exponential. So you don't want to have to type these in all the time, or maybe you do, but I like to just turn them off. And then what we're going to do now is we're going to turn on or put in the exponential equation. Okay, so I'm adding one more. And does anyone remember what that exponential equation was? Y1. Remember, we have to use the tilde instead of equals. And what was the expression? Not mx plus b, but that was the ab raised to the x, right? So we just use a times b. You can, I'll show you, you can do a shifted 6, the little chevron, I think they call it. Or you can do this button, a to the b, that will give you your exponent. Okay. So now we're up in the exponent. We want to put x, and we want to put the 1. And notice it drew the graph, drew the line, the curve in there. But it's not exact. It's not going to be the accurate one. This is, and I was working with the other classes. They would forget this. I forget this. We need to check log mode. What's that? The X above. You do this button here, A to the B. So that, if you, pull up the keyboard. So the keyboard's usually down, but you can pull it up, and you can do the A to the B button. And you want to check log mode every time you do this, or leave it in but once you get it. We need to do log mode. Your answers will match. They will match the TI-84 calculator if you're doing this. They will match the answers in the homework. If you don't, your answers won't match, and they'll say you're wrong. And so it's using, and what is log mode? I know what logarithms are, but it's just having how they're calculating it. And this is the one I guess you can do both. Again, what we have here is, we've got our value of A. Okay, that's going to go this part of the equation. We've got our value for B, and that will go here. So when the homework is asking us for the exponential equation, right, we're going to give it the answer, y equals 82.943. That's rounded to 3 decimal places if the instructions say to round to 3 decimal places, right? Took the 2, gets rounded up, times the value of B, which is 0.83. And if we want 3 decimal places, it's a 6 that's going to get rounded up because next to it is a 6, so 837. And then for our answer, we have to put the exponent up here of x. Or t. Watch, be careful. Sometimes they want t, sometimes they want n. They use different letters for that variable. Okay, but we just gave it the answer. That's what they want. We just did a different type of regression that will fit different type of data. So when we got sort of data that's based on percentages, which typically will happen with population changes percentage-wise. You get less people as you're going down, then less and less. It's usually a percentage change. or if you're even when you're increasing, usually increasing by a percentage. Money, invested money is as a percentage change. We'll see those, all those types of things. Okay. Again, it's not a perfect fit, but look at this. Our R value is 0.97. That's pretty close to 1. If you remember, well, actually, we don't have to remember. So this is part of what we can do. The linear equation only had an R value of negative 0.8. It was less, it was further away from 1, right? Negative 1. So we could say by the R value, this one's closer to negative 1. This is the better fitting equation. And we visually can see it too. It looks like, oh, it's fitting this pretty doggone good. So far, so good? Okay. Now, again, for the homework, they will ask the same type of questions. They'll say, well, in 15 years, what was the value, right? We're going to do the same thing, but if we give them a rounded equation, we need to put in a rounded equation here. We can't use the one that Desmos created because it's too accurate. Okay, so then we're going to add this expression. We're going to add in the same expression we put into the homework as an answer, y equals 82.943 rounded, 0.837, oops, 837, and we're going to raise it to the x power. And again, the way you can get the exponent, you can click on this A to the B button, and that gives you your exponent. Put that as x. And now we've got this purple, which is very close, but it's rounded. It'll give us slightly different answers. Okay. So I turn off the green one. I'm going to use this purple one. Oops. Get this out of here. Get this out. Okay. So far, exponential regression. Get it all done. And again, if we need to figure out when x is 15, we add an expression, x equals 15. If that was a question, we get a vertical line, and we go to where they intersect. And that's going to give us a line. When after 15 years, our value is 5.74. Maybe we round it, but we've got our answer right there. Okay. What if they ask when is, you don't know what the values here are. Sometimes they tell us, sometimes they don't. This is population. So if the question was, when is the population 50? Well, it's kind of there. How about when is the population 60? When is the population 60? Well, that's a y value, not an x value. So in that case, we put in y equals 60. Oops. Y equals 60. We get a line at that, find their intersection. Oh, that's in year 1.8. Maybe they wanted rounded up, we call it 2 years, whatever, but we get our answer that way as well. So that's what they're going to ask. So they'll ask you to find the equation. We did that with Desmos. And then they will, for some of the questions, they'll ask you, when x is this, what is y? Some of the questions, when y is this, what is x? Okay. So we're either putting in a vertical line for x equals gives us a vertical line, y equals gives us a horizontal line, and we're looking where does it intersect the regression curve. But just be careful, you have to put in the rounded equation. Otherwise, your answers are going to be too accurate and they won't match, and they'll say you're wrong when you're not really wrong, you're more right, but you just want to get the points on that. Does that make sense? Okay. Now we're ready for the homework, or the quiz, the homework quiz, I think. Make sure we've gotten through everything. So what is the one thing that you want to really be careful about when you're doing exponential regression? Log mode. Make sure you're in log mode. I still forget it from time to time. Okay. And then also remember the two different types of equations. Okay, those come from the homework. All right. Let's see. I think we're just, so we did that. We could do another example. We don't need to. This is one where you maybe do both. Again, another. So there's just some chances. Let's just go ahead and do the quiz because we'll get more practice. So the quiz. Close that one. Close that one. Close that one. So now we're going to go to the chapter 4 quiz. Reset. Okay. So the first one is just they want the equation. So they give us the x and the y values. I'm going to go up here. So I'm going to put them up here. Again, we're going to enter these into Desmos, and we're going to get the equation. And notice they want everything rounded to 2 decimal places. The instructions are here. Use linear regression to find the equation for the linear function that best fits this data, down to 2 decimal places. So for that, we go into Desmos. Okay. I'm going to turn off my exponential. I'm going to leave my linear equation here. I've got my table ready to go. I just need to get new data in there. So maybe go back and delete it. Or you can type over the top, whichever you want to do. I'm going to delete, and then let's put our data in. I've got it up there. So I've got my x values, 1, 2, 3, 4, 5, 6. So I enter those. Enter my y values, 652, 663, 713, 737, 761, 778. And again, just be careful that whatever, that you put in the right numbers and that you check, because garbage in, garbage out, right? So far, so good. And again, if you're doing the quiz, you'll probably have slightly different numbers, but that's the way this thing works. What we're looking at mainly is to get the process down. So what would be a good window to look at these? Well, I see my x is going from 1 to 6. So on my x-axis, I'll go from -1 to 8. Again, just to be able to see it all. That's something. Oh, I still have this one. I'm going to delete that other one. My y values are going from 650 to 778. So I'm going to take my y values from maybe -5, just because I like to see the x-axis, and I'll go to 1000. That'll include all my data. Okay, so I can see my data points. And again, yours, you could do slightly different, but just make sure if you can see all your data, then you see what's going on. And again, does that look kind of linear? Yeah, it looks like we could probably fit a nice linear equation. And the thing is since we already have y1 tilde mx plus b, we already have it set. We just turn it on, and it will take that new data. That's the nice part, is we don't have to re-enter all this. There's our line. Looks pretty good. I look at my R value, it's 0.98. Oh, that's a very good fit. It's close to 1, right? It's increasing. And I've got my equation right here. So my equation, I'm going to write it here first, and then I'll put it into the quiz. So right, they wanted it rounded to 2 decimal places. So my equation is y equals, this is the slope. So I'm going to do 27.0 0.09, that's 2 decimal places. The 8 gets rounded up because there's a 5 next to it. In my, again, yours may be different. I put my x plus, and then my b value, 622.53. And again, that's the y-intercept. So that's really that projected value there. But this is the answer. That's all they're looking for, is what is the equation of the line. Right. So that would be the rounded answer. And I'm just going to, but the important thing is to see where that's coming from. So B comes from here, number there. M comes from here. And then you've got your Y and your X. And then when we go over to the homework, instead of putting in, I'm just going to click here. Notice they got it in a different order. But if I would have put in, wow, they say round it to 2 decimal places, but they don't actually do it. 27.09 x plus 622.53. That's what we had. And if we check our answer, it's going to mark it correct. But on mine, I can also show an answer, but they just didn't have it properly formatted. So far, so good? Sure.
When you fix it with the little wrench and
Uh-huh.
Cosmos, how do you determine?
Perfect. Good question. I'm looking at my table here. So I'm looking at, so when I do the wrench, I'm looking at what are my Y values. And I see they're from 652 to 7, almost 800. So I just want to be able to see it all, but I also like to see the x-axis. So I like to be, which is way down here. So I would go at least from, say, y equals 0 to about 1,000, because I said 800. And I'm just, it's all an estimate, but I just want to make sure I can see it all. I wouldn't go to only 600 because I got data above that. So that's what I'm doing when I'm hitting the wrench. It's sort of just estimating it. And then the x values are going from 1 to 6. So because otherwise, if you go too far out, like if I had x going from 1, let me just show you. If I went to 1 to 100, then it's, all my data is over here. It's just, I can see it, but it's just not as pretty, right? I don't need to go to 100 because I don't have stuff out at 100. I could maybe go to 10 or 15. So it's just good. It's not a science, and there's no right or wrong to it, but it'll be perfect. Yeah. So far, so good. Because if we can do this, pretty much everything else is going to go from here. So let me clear out this data. Go back and see this question 2. You'll see we got data, right? And this time, determine the linear regression equation that models the set of data above. Use this equation to answer these questions below. Now, this time, they're not asking us to give them the equation, but they want to answer the question. Okay? And so we have to read a little carefully. The table shows the value. So V is the value of the investment in years after 1989. So 1 year after 1989, 3 years, 7 years, 12 years, so forth. So again, all we're going to do is go to Desmos. We're going to put this in. They're telling us it's linear regression. That's y equals mx plus b. So we just come to Desmos. We're going to leave the linear turned on. I'm going to come and delete this data. Because if you don't, you could put in a new table, but then your new table is going to be x2, y2, and you'd have to redo your equations. Okay, so I just find it easier to put in new data. I'm going to do that. And we put in our data. X is the years 1, 3, 7, 12, 14, and 19. And then I come back and put in the y values, 9,181. And again, yours, you're doing your quiz, you might have different numbers. 11,467, 13,773.16, 14,134, and 15,237.05. Okay, so I got, again, I checked. I think I got it all right. That's really all I need from this at this point. So I'm going to make my table a little bigger. And I'm going to go to the wrench to set it up. My window, my X's are going from 0 to 19. So I want to see at least to 20, maybe to 30. I'll go to 30. I like to be just a little bit to the left of the y-axis, so I'm negative something. The y-axis, negative something to, what's this value? Oh, it's 15,000, right? Maybe I'll make it 20,000. So I make the upper one, again, just enough so I can see everything. There we go. Now I can see it. That's good. You could go to 30, sure, 30,000. Oh. Yeah, the X's I went to 30. I went from 0 to 20,000. And again, we look directly at this table just to make sure we can see it all. So we want to do it a little bit bigger. And again, there's no right answer to that. But just, and I've done this because I've been doing this for 26 years. And again, a lot of times I would do it wrong, but then I'll do it right. It looks like I know exactly what I'm doing. It's just that, yeah, I've done it for so many years. You get practice, you get good at something. And they pay me to do this, so when they pay you to do something, usually you get better at it, right? So far, so good. Looks like a good fit. We've got the equation, but they didn't ask for the equation. But we've got to think about here, what does the value of m give us? Right? This gives us our, oops, I'm this down here. M gives us our slope, our rate of change. So that's each year, that's how much it's going up. B gives us the initial value, right? The y-intercept. It's this point, like right here, okay? So these are actually where the answers are going to come from. So if we look at those answers, if we go back to the quiz, quiz is asking, based on this regression model, the value of this investment was blank in the year 1989. 1989 is year 0, right? Because that's what they're saying. The time is years after 1989. So that's a way of saying 1989 is year 0. So this is our value, is B. This is coming round the answer to the nearest hundredth as needed. So we're going to go back. B is $8,913.32. That's what we want to put in. And if you want, a little lazy like me, you can do that and Control C. You can actually copy that and go back to your decimals. Let's see if this, I don't know if it'll work. And Control V, it pastes it in. That's kind of, once you get doing, sometimes that's good because otherwise you may copy, you have to put it back and forth. But you can copy and paste these things. Okay, but that's what they're wanting there. And I'm just going to do a check. That's exactly what they wanted. Okay. Based on the regression model, the value of this investment is it increasing or decreasing? Let's take a look. Is that line going up or down? It's going up, left to right. And our slope is positive, increasing. And then while we're here, they're going to want the slope. So I'm going to copy that. They want the value of M. Control copy, $358.15. So that's the other question. Based on this regression model, the value of this investment is increasing at a rate of $358.15 per year. And again, I can just click on the answers, it's correct, or you can do check the answer and you got it all right. So notice we just put the numbers in, we've got it set up. Desmos will give us these answers. Sometimes they want us to write it as an equation, y equals mx plus b. Sometimes they just want those values. So we have to know what is m. M is the rate of change. What is b? B is the starting value. Exactly. Slope is going to give us the rate, and that tells us whether it's increasing or decreasing.